While searching for pictures for the electrical video, we discovered the ceiling fan installation. We'd forgotten we had this picture, so I'm going to go over it right now. Ceiling fan, this is the rear ceiling fan looking in from the rear doors. Several important things here in this picture. First of all, you can see how the ceiling fan is fastened with these stainless steel sheet metal screws. Also, you can see how the wiring is connected up to the rib. We used nylon loops to secure the wires to the ribs above the ceiling panel. That way they wouldn't be rubbing against the ceiling panel. Not all the loops are installed in this picture, just a couple of them. The other thing is we use stranded wire. We use solid stranded wire when we ran out of the duplex stranded wire. You should never use solid wire in a moving vehicle. So all of our wires are stranded. In this picture you can see where the forward ceiling panel is attached to the fourth rib back from the front, fourth middle rib back from the front. And then we attached the back ceiling panel to the same fourth rib and then the board as described in earlier videos. You can also see that we stuffed all the voids here on the left hand side with rock wool to help soundproof the van. And you can see how the ribs bend down on the left hand side here. Those ribs are what we attached those boards, those plywood boards to inside the cabinets to hold the additional rock wool which is placed between these ribs and down the walls. Here's a roof view of that rear ceiling fan, how it's offset to the left. Here's a roof view of the forward ceiling fan. In our original plans, we wanted this to be offset to the passenger side of the vehicle to get a good crossflow between the front and rear ventilation fans. As it turned out, there was a metal platform stamped into the roof that we needed to use, so we put it in the center. Here's an inside view of the forward ceiling fan. You'll notice that there's a hole with wires hanging through it. We drilled that pilot hole before we installed the roof fan, so we didn't know the fan had to be in the center. So that hole would have been the center of the 14-inch rectangle we're going to cut out of the ceiling panel, but instead it's off to the right. In other pictures you'll see this hole plugged up with a plug. It's black in color. Eventually we'll get that painted white. Each of these batteries is a 200 amp gel cell, and it's such a large size that we couldn't find an enclosure for them. Even the manufacturer of the battery does not sell an enclosure for these large batteries. So we built our own battery tray out of 1.5-inch angle iron, 1/16 of an inch thick, and we bolted the angle irons through the floor to the bottom of the van. To hold these batteries in the tray, we had angle iron across the center top of each battery and long bolted down through the floor so the batteries could not jump out of the tray. We placed the batteries on the passenger side of the van near the wheel well and up almost to the sliding doors that separate the garage portion from the forward portion of the van. We did this for 3 different reasons. The first reason we placed the batteries in this position was so that the garage doors could slide open. We could place long items inside the van through the rear van doors. With the batteries centered on the van, you wouldn't be able to do that. The second reason for this battery location has to do with weight distribution. These batteries are heavy, they're on the right side. The wall cabinets on the driver's side of the van will also have most of our storage items in it, so it'll be heavy too, and that'll help offset the weight of the batteries. The third reason for this location has to do with access to the DC circuits. The DC switch panel is going to be above the sink cabinet, and the inverter, which draws a lot of current, is going to be on the end of the sink cabinet by the sliding door. So this minimizes the amount of wires required, I should say minimize the wire length required to hook up the DC circuits. We used 1/8-inch rubber sheeting to line the battery tray bottom and the battery tray sides, and also underneath the battery hold downs, just preventing anything from rubbing on the battery and rubbing a hole through the gel cell batteries. Next, we built a wooden box which surrounds the batteries and protects them. And this wooden box fastens to the battery tray. And we decided to put the battery charger right on the end of this battery protection box. Right now there's no lid on the box. There will be a lid on the box eventually. First we have to use a hole saw to drill ventilation holes through the sides and the lid so that the batteries remain cool while they're being charged and discharged. Here's a close-up view of the 300 amp battery select switch. Number 1 battery is on the left lead coming into the switch. Number 2 battery is the right lead coming into the switch. And the middle lead going back into the box is the output of the battery switch. There's a fat red wire also coming off that same terminal. That is where the solar charger charges the batteries. And the skinny wire coming off that same middle terminal is what feeds our DC electrical distribution panel. This battery cutoff switch will have a protective box around it. We wanted to switch outside of the main battery box. That way you could easily reach it through the sliding doors from inside the van and kill the batteries if required. Also, if one battery gets a short or something, we can always just use the other battery and isolate that battery. Here you can see the battery box shelf. At the far end there you see the battery cutout switch, which is boxed in so it can't be damaged by things bumping into it. And then if you look in this picture here, you can see that there's a space between the battery shelf and the top of the battery cover. This cover has 18 holes, 1.5 holes drilled into it to let the heat out, and this space allows the heat to move outside of the batteries. Here we're looking through the driver's door at the 400 watt inverter that's mounted behind the driver's seat. It's mounted on the front wall of the hanging closet. Here's another view of the 400 watt inverter with the driver's seat swiveled to face aft. This 400 watt inverter connects to the vehicle battery through a relay. When the ignition switch is on, then this inverter pumps out 120 volts AC up to 400 watts, and that's going to be used to charge the batteries while the van is being driven. Inside the hanging closet there are 3 components. There's the blue electrical connection box, there's the red wired fuse, and there's the black AB, automatic AB 30 amp switch. This fuse is very important because we didn't want the inverter trying to charge its own batteries while it's using battery power. So the shore power circuit coming in here could not go through the normal shore power circuit breaker panel because that is fed by the inverter. So instead we ran a separate shore power wire up to this connection box via this fuse, so that the shore power is fused by this inline fuse. The black box AB switch receives fused shore power from the blue box. It also plugs into the 400 watt inverter behind the driver's seat. And that's the 2 sources for this automatic AB switch. It defaults to shore power, and if the vehicle power shows up from the 400 watt inverter, then it switches over to that. That way it's an automatic switch over. If the engine's running, it'll take control. You don't have to worry about turning on the 400 watt inverter. It does it automatic when you start the engine. If you're driving a vehicle, you won't have shore power connected, so it all works out. The AB switch outlet output, 110 volts AC output, goes down through the blue connecting box and runs through a wire all the way back to the outlet box at the rear of the van near the battery charger. And that's where the battery charger plugs in. At the top of the battery box we have 2 electrical items installed. We have the 200 amp fuses, 1 for each battery. We also have the 300 amp battery charge discharge sensor, which feeds a meter up at the front, which tells us the battery charge state. All of the battery DC circuits run through this 8-position switch box. It has 8 switches and also has 8 circuit breakers. And everything that's driven by the battery goes through this box, including the USB charging jacks that are placed throughout the van. The 40 amp solar charge controller and the 2000 watt inverter were mounted on the end of the kitchen sink cabinet. This provides good airflow to keep both units cool during operation. This is the panel view of the 2000 watt inverter. We have 2 function switches and we have 2 USB charging jacks, and we'll have 1 spare 120 volt AC jack. This spare voltage can be used if we want to plug something in outside of the van. This is a view of the bottom panel of the 2000 watt inverter. The thick cables are directly from the battery switch, the red one and the black one. And the thinner cables are from the charge controller to charge the batteries. So those connections are made right here. The 3 solar panels are 160 watts each for a total of 480 watts. They're wired in series and they feed down to the charge controller through a 30 amp fuse. Here's a bottom view of the charge controller. On the left we have a temperature sensor, which is a metal unit that bolts to the positive terminal of one of the batteries. That lets the charge controller know the temperature of the batteries. We don't use the load feature of the charge controller. Instead, our DC load is tied directly to the battery switch. We are planning to move the 8-position DC switch above the sink. We're planning on, instead of connecting that to the battery switch, we think it'd be smarter to connect that to the load terminals of the charge controller. This way, if we leave the vehicle and leave on some DC appliances, lights, things such as that, then the charge controller will sense when the battery voltage gets too low and it'll shut off all those DC circuits. That'll protect the battery from being drained below a voltage it shouldn't go below. The 2000 watt inverter is direct tied to the battery switch, but that's okay because the inverter senses voltage and shuts down when the voltage gets below a certain minimum. So this way the battery is protected with the charge controller's load system, and it's protected by the inverter if it's left on, sensing a low battery voltage. The house AC components only consist of the master breaker panel and the automatic AB switch. This AB switch switches between shore power and inverter power automatically. It defaults to shore power if that's not available, and if inverter power is available, then it switches to inverter power and sends that to the main house AC breaker panel. Here are both panels with the covers removed. The right-hand panel is the automatic AB switch. Like we said earlier, it determines what kind of AC power gets sent to the house AC breaker box, whether it's inverter power or shore power. That's its only purpose in life. As I said earlier, if the shore power is not available and the inverter power is available, then it waits 30 seconds with inverter power before it switches to inverter power. The house breaker panel contains a 30 amp master breaker and 4 15 amp line breakers. Obviously 4 times 15 is 60, so we can't pull 15 amps on all 4 circuits at the same time. This master breaker in this box is fed by the automatic AB switch, which either sends shore power AC to this box or it sends inverter power AC to this box. All of our appliances are plug-in appliances except for the heat pump, which has its own circuit breaker. So the rest of the installation of the AC is basically just installing electrical boxes where we need them. Now we're going to explain our van conversion wiring diagram. This is called a functional wiring diagram. It makes it easier for laypersons to understand how this thing is all connected. You notice there's a color code. 115 volt AC items are blue and 12 volt DC items are in green. These colors were chosen for good contrast between the black print and the colored box. We'll start with this 30 amp shore power receptacle. Notice it goes 2 places. It goes down to the automatic 30 amp AB switch for the house AC panel. It also goes up to the shore power in for the automatic AB switch for the battery charger. We discussed this earlier. What's shown here is the fuse between the shore receptacle jack and the automatic AB switch for the battery charger. The automatic AB switch for the battery charger also receives AC power from the 400 watt vehicle inverter. So it depends on which source feeds the AC output of the battery charger AB switch. It feeds down here to the 20 amp gel cell dual battery charger input. So that's how we power the battery charger. The automatic AB switch for the house AC panel receives shore power from the power receptacle, or it receives inverter power from the 2000 watt inverter. And one of those two is switched over to the house breaker panel. This breaker panel contains the main master breaker and also all the circuit breakers for the van conversion. And this concludes the AC portion of the functional wiring diagram. To charge the house batteries while we're driving, we use this vehicle battery, which drives ignition relay, and a 30 amp fuse, which feeds the 400 watt vehicle inverter. And you've seen how that gets to the battery charger. Shown here are the two 200 ampere hour house batteries, which are connected, the positive terminals are connected to the battery switch. The negative terminals run down through 200 amp fuses, then down through the 300 amp battery monitor, down to chassis ground. Next we look at the 480 watt solar panels, 3 panels in series, which connect through a 30 amp fuse to the solar charge controller. Solar charge controller, the right side of it is connected to the battery switch, which is the batteries when the switch is turned on. And finally, this battery switch is connected to the 2000 watt inverter, and the 40 amp charge controller load terminal is connected up here to the DC distribution switch assembly. And last but not least is the water pump circuit, which is also tied to the load circuits. And this concludes the electrical video.